Okay, so now we're going to do lesson 3-2, angles formed by parallel lines and transversals. So today's objective is to prove and use theorems about the angles formed by parallel lines and a transversal. So for the first four things that we're going to write, they all are going to start with if two parallel lines are cut by a transversal. So instead of rewriting it 4 times, I just wrote it once up here. And we'll remember that it's on all 4 of them. Okay? So let's do the first one here. If two parallel lines are cut by a transversal, then for the corresponding angles postulate, we can say that corresponding angles are congruent. So we have 2 lines here, and I'm going to show you, I don't know if you know this or not yet, but if you want to show that the lines are parallel, then what you do is put a little arrow on them, and those 2 are parallel lines. If you see a double arrow on one but not on the other, these 2 would not be parallel. So if I do a double arrow on one, if they're parallel, I have to do a double arrow on the other. So that shows me that the 2 lines are parallel to each other. So here's my transversal, and if we're doing corresponding, we need to have all of them. So I'm just going to label these angles. And what we know is that if the lines are parallel and they're cut by a transversal, then all the corresponding angles are congruent to each other. So angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Angle 5 is congruent to angle 7, and angle 6 is congruent to angle 8. I also want to show you something else here. Usually when you have 2 lines, the parallel lines cut by a transversal, it's usually really obvious that you have obtuse angles, and you'll see that I have obtuse angles here and here. I also have obtuse angles on 6 and 8, and 3 and 8 are equal because they're vertical, and that means 6 and 8 are also equal. So you have 4 congruent angles here that are obtuse. And then the other angles are also congruent to each other on all 4. So if I told you one of my angle measures, so if I said this was 120, then you would know right away that this should be 60. This would be 120, and this would be 60. This would be 60. This would be 120. This would be 120, and this would be 60. So if I gave you one angle out of all of these 8, immediately you should be able to tell me what all the other angle measures are because they're parallel and corresponding angles are congruent by this corresponding angles postulate. Okay? The next one is alternate interior angles. So if we have these 2 lines are parallel and they are cut by a transversal, now we have alternate interior. So we're just going to be looking at these 4 here, the interior ones. So they are congruent. So angle 1 is congruent to angle 4. And once again, remember an acute angle and an acute angle, you should be able to know that those 2 are equal. These 2 are both obtuse, so that means they're also congruent. Angle 2 congruent to angle 3. And that's only true if it's parallel. And I told you that you could usually see which ones were congruent. The only times you can is if it's close to 90. Because if it's close to 90, then it's a little harder to see it visually. But when it's a little bit more obvious, you can see, like, you know, if the transversal is in a little bit like this, so you can see that we have 2 acute and 2 obtuse. So we can say that alternate interior angles, if 2 lines are cut by a transversal, then alternate interior angles are congruent. Okay, now we're doing alternate exterior angles. So we would say if 2 parallel lines are cut by transversal, then alternate exterior angles are congruent. So here we have, I'll draw my transversal this way this time. We have 2 lines that are parallel, and we're dealing only with exterior angles, so I'll only name the exterior angles this time. So alternate exterior would be 1 and 4. and 2 and 3. Okay, now a lot of students want to say, oh, I know what this one is. All the rest of them were congruent, right? Congruent, congruent, congruent. Therefore, this one, oh, it must be congruent too. Don't be so hasty. Wait a second and watch. This one, let's take a look at it. If I have two lines that are parallel, and I want same side interior, so that means I want this angle here and this angle here. Well, you'll notice that I have one that is obtuse, and this one is acute. So they can't be congruent. But instead, the same side interior angles are supplementary. And remember, that means they add to 180 degrees. So if I'm labeling these 1, 2, 3, and 4, then I could say that the same side interior angles are supplementary. So the measure of angle 1 plus the measure of angle 3 equals 180. And the measure of angle 2 plus the measure of angle 4 also equal 180 degrees. Okay, so there we have that. Now let's take a look and explain why each of these theorems are true. So remember, part of what we were going to do was use the theorems, but we're also going to prove these theorems. Why are these two angles, these three different theorems true? So we have a corresponding angles postulate. We're going to assume that angle 4 is congruent to angle 3. That's given to us. So if that's true, why are alternate interior angles congruent? So we have 3 and 4 are congruent, so we can say angle 3 is congruent to angle 4 because of the corresponding angles. Now we can say that 4 and 2 are equal, right? Because they're vertical. So angle 4 is congruent to angle 2 because they're vertical angles. Therefore, if 3 is congruent to 4 and 4 is congruent to 2, you should be able to say then that angle 3 is congruent to angle 2 because of transitive. Okay? Now, why is the alternate exterior angles congruent? So we're going to start again with 3 and 4. So angle 3 is congruent to angle 4, and these are corresponding angles. Now we want to get from 3 and 4 to 1 and 4. So I'm going to use vertical angles again for 3 and 1. So angle 3 is congruent to angle 1 by vertical. Now we can say then if 3 is congruent to 4 and 3 is also congruent to 1, we can say that angle 1 is congruent to angle 4, and again that is transitive. Okay, same side interior angles. So this time we're going from 3 and 4 to 5, or sorry, let's do 1 and 2 this time because they have 5 listed. So let's do 1 and 2, and we want to get from 1 and 2 to 5 and 2. So we'll say angle 1 is congruent to angle 2. Those are corresponding. Now let's talk about, we want to get from 1 and 2 to 5 and 2. So we already have a 2, so we need to change the 1 into a 5. So remember, same side interior angles theorem says that 5 and 2 are supplementary. So we need to say that 1 and 5 are supplementary. Angle 1 and angle 5 are supplementary. And the reason why is they are a linear pair. Okay? So if angle 1 and 5 are supplementary and angle 1 is congruent to angle 2, I can substitute and say that angle 2 and angle 5 are supplementary by substitution. And there I have it. I just proved all 3 of these theorems based on the postulate of corresponding angles. So there we have it. Okay, have a good day.